Reading Science A, Seafloor Spreading and Plate Tectonics, Ridges and Trenches. More than 100 years ago, geologist Alfred Wegener made an interesting connection. Wegener realized that the coastlines of America and Africa fit together like a jigsaw puzzle. Also, similar fossils are found on both continents. He proposed that the continents had once been joined. They had later drifted apart. He did not know how this continental drift happened. New technology was required to discover the underwater ridges and trenches that made continental drift possible. Most scientific discoveries combine observation and inspiration. In the 1950s, Marie Tharp and Bruce Heezen led a team of geologists. They made the first scientific map of the ocean floor. They sailed around the ocean. They made many measurements of water depths. They found a vast mountain range running along the middle of the Atlantic Ocean. They named it the Mid-Atlantic Ridge. At first, they thought that this ridge was unique to the Atlantic Ocean. Later, they found that ridges are in most oceans. These scientists discovered that the mid-ocean ridges existed. They still don't know how they form. Later, studies by other scientists provided clues to how mid-ocean ridges form. Geologists measured the magnetic properties of the ocean floor near the ridges. They found a pattern of stripes. Rocks record the magnetic orientation of the Earth at the time that they were formed. Earth's magnetic field flips orientation every few million years. Therefore, the stripes alternate. Importantly, the stripes are the same on both sides of the ridge. This suggests that the rock moves away from the ridge in both directions. Geologists found the age of the rocks at different distances from the ridge. Their data showed that the younger rock is closer to the ridge. The older rock is found farther away from the ridge. The last piece of evidence is from the pictures of the ridges. The ridges show lava flow, like those seen on volcanoes on land. These observations led scientists to propose that the seafloor spreading is part of continental drift. This is also known as plate tectonics. The theory of plate tectonics explains how Earth looked in the distant past. It explains many modern features. Plate tectonics allows us to predict how the Earth might look in the distant future. You now know that the seafloor itself moves. It carries continents with it. The entire crust of the Earth is divided into about 15 plates. These plates move on top of the semi-solid mantle. The movements are powered by a convection current. The new crust forms at the mid-ocean ridges and moves away from the ridges in both directions. The plates are moving away from each other. Therefore, these areas are called divergent plate boundaries. Between 2 and 20 centimeters of new crust are formed at the mid-ocean ridge. A fissure in the Earth's crust allows magma to erupt. It then cools into new crust. Eruptions and small earthquakes are common along the 65,000 kilometer of the mid-ocean ridges circling Earth. The formation of the new crust increases the distance between the continents and makes some oceans bigger. New crust is being added continually at the mid-ocean ridges. Does that mean the Earth is always getting bigger? If addition of new crust were the only process at work, the answer would be yes. Some scientists do think the Earth is actually getting bigger. However, most scientists think the Earth stays pretty much the same size. To keep the Earth the same size, crust must be destroyed at the same rate it's being created. In fact, old crust is destroyed at convergent boundaries. Old crust comes back into the mantle through the process of subduction. How does that work? Continents are carried along the moving plates. Some plates collide and break apart. These movements cause the earthquakes and volcanic activity. Here's where the ocean trenches become important. Ocean trenches are also called submarine valleys. They are the deepest part of the ocean. Scientists must use special submarines to explore the trenches. The water pressure is very high at these extreme depths. The pressure can be equal to a car sitting on top of 1 square centimeter. The Mariana Trench is the western Pacific Ocean, reaches depths of up to 11 kilometers. Mount Everest is the tallest mountain on Earth. Mount Everest can fit into a trench with 2 kilometers to spare. These trenches form where 2 tectonic plates come together. This is usually a continental plate and an oceanic plate. The oceanic plate is denser. It gets pushed under the continental plate. The oceanic plate goes back into the mantle and melts. This process often creates earthquakes or hot spots that cause volcanoes. A perfect example of this is an area known as Pacific Ring of Fire. This large area forms a horseshoe shape around the Pacific Ocean. It runs along the eastern coasts of Indonesia and Japan, north to Russia, then extends to the west coast of North America, all the way to South America. It has the largest number of active volcanoes and destructive earthquakes on the planet. Most of the activity is due to subduction of the seafloor under the tectonic plates at the continent's edges. The basics of the theory have been worked out over the last century. Research is still discovering new aspects. 2 large earthquakes were recorded in the Indian Ocean in 2012. These earthquakes suggest that the Australian and Indian plates are separating. The actual separation will probably take several million years. Large earthquakes, however, might become more common. Geologists have studied earthquake waves passing through the crust near the California coast. Data shows that the chunk of an ocean plate is still stuck at the bottom of the continental plate. Subduction may therefore not always be smooth. Research also shows that the Earth may not be the only planet with plate tectonics. A large canyon system on Mars seems to have fault lines. Fault lines often make plate boundaries. Several long lines of volcanoes suggest that plate tectonic movement slowly over a hot spot.